So who here would identify as a data engineer, analytics engineer, data analyst, or otherwise doing data hands-on? Okay, very cool. So hopefully my talk going to be relevant. So who is, generally speaking, absolutely confident in the quality of their data they produce, they consume, or otherwise deliver to their stakeholders? Okay. 3 people. I'll talk to you after the event. We're going to invite you to Data Quality Meetup to learn how you do this. So, cool. Data quality is a big problem. So for those of us who are doing this routinely, we used to get questions like this, or this, even worse, or that, probably the one I dread the most. And data quality is a really, really big topic, just like software quality. There's no single answer, no single solution, and it's likely is to be solved with not just tools, but also culture and processes. But since I'm making tools and I was asked to do a demo, we're going to talk mostly about tools that we can use to improve data quality for analytics, machine learning, and otherwise putting data to make your business more data-driven. So as a very complex topic, I think it's useful to break it down into first principles and start with something simple. So I believe there are fundamentally 2 types of data quality issues. Anyone has a guess? Okay, I'll make it easier. So it's either, from a data team's perspective, it's either us breaking data or them breaking data. So what does it mean? Us breaking data means that we, the data team, data engineers, software engineers, building pipelines or otherwise touching data applications, make changes, introduce bugs, do something wrong, right? So just like in software, bugs don't appear by themselves, we introduce them. So examples of that are simple hotfix or refactor. In my years of data engineer at Lyft, I was unlucky to break down, well, actually blow up the entire data platform by making a 3-line SQL code hotfix that filtered a little bit more writes than I anticipated. Adding columns, not backfilling things properly, changing definitions, not telling other people. So those are things that we introduce. What are the things that break outside of our control? So the examples of that are infrastructure failures. For example, your Airflow orchestrator scheduler is broken, or your cluster, like Spark cluster, is underwater and backlogged, or your vendor that you use to buy data ships you something which is of low quality. And the interesting question is, what do you think is the breakdown between us breaking data versus us, meaning data teams, versus data breaking outside of our control? Infrastructure vendors, other teams. Is it A, B, or C? Who thinks it's A? Who thinks it's us breaking data for the most part? Okay, a bunch of self-aware folks here. Who thinks it's B? Half and half. Okay, C. Cool. So I'm more in the A camp. So what do we do to address data quality? If you're familiar with modern data stack, dbt, Airflow, the general ecosystem, currently there are 2 mainstream approaches to solving this. One of them is data monitoring. So the picture at the top. Basically, we apply some machine learning rules to learn about the behavior of data, monitor all tables and columns in the warehouse, things like row counts, percentage of nulls, other metrics of quality, and then we get alerts whenever things are looking abnormal. The second, and examples of, for example, solutions that are in the data monitoring space are, for example, Monte Carlo, Big Eyes, Soda, LightUp. The second type of data quality checks are called data assertions or data tests or data unit tests. There are many names, or expectations, by the way. The idea is that we define what data should be like. For example, a given column should be one of these 5, 6 values, or should be not null, and we codify them. And then we can check those things either when we are developing and making changes, or in production every day, every time the pipeline runs and That way we can make sure the data is correct. So who is using either of those today? Data tests, data monitoring in their workflows? Okay. Well, there are solutions that you can adopt for that. Examples include DBT tests, Great Expectations, and also lots of open source frameworks that are somewhat less popular. The approaches that these two approaches have different strengths and weaknesses. So for example, data testing is basically us writing unit tests for data are not scalable, whereas data monitoring is scalable because we can just automatically track data in the warehouse and automatically provision machine learning to track data for anomalies. The signal to noise in data testing typically tends to be better because we define exactly what is wrong, what is right, versus in monitoring, it's quite noisy because it just tells us when data doesn't conform to the historical properties, which doesn't mean that it's actually broken. With data testing, we can't detect unknown unknowns because if we haven't written tests, we don't know that we wouldn't know about the failure. Whereas data monitoring, because it's unsupervised, would likely pick that. And detect and dev means that when we are making changes back to us breaking stuff, right? Can we use this to actually prevent breakages by testing our work before it ships to production? And then finally, considers business meaning. So it's a very important concept because if we're using data testing, we can codify our business assumptions about data. For example, I know that the product type is one of the 4 values for my business, so I can write explicit tests for that. Versus data monitoring just learns how the data looks. It doesn't know what actually makes sense for the business. So there are multiple trade-offs here. So those are 2 solutions that are very popular right now. Those are 2 solutions that I've used as a data engineer at Lyft and other companies where I worked. The problem is that they're quite different, but I always feel like something is missing. For example, when I make change to data pipeline, I have to write tests to make sure I don't break things, and that doesn't scale. And monitoring won't catch things until they get into production. It's like very reactive. So what I wanted to have at my disposal is a tool that would be catching all issues as much as possible, would be scalable, so it wouldn't require me to write some tests and spend a lot of time on that. Would be great with signal to noise, would detect unknown unknowns, so I wouldn't need to think about all the possible ways they could break, would be applicable to the developer workflow, and maybe would consider business meaning. So that tool felt like was missing in the workflow, so that's what we decided to build a Datafold. And this tool is called Data Diff. So what's Data Diff? Data Diff is a very simple tool. It essentially helps you compare 2 data sets and tell you how they are different. Very simple concept, but very powerful one. And I'm going to show you how that applies to the data engineering workflow. So first, let's consider the use case for we break data. Okay, so a typical example of a day of an analytics engineer or a data engineer is, let's imagine we are running an e-commerce business selling craft beers, and someone, let's say a product manager, asks us to change the definition of beer bitterness based on the IBUs, the bitterness units. So we used to have 2, malty and hoppy, and we changed the SQL logic, so now we have 5, so it's a little bit more granular. So what we do is we go to GitHub, we open a pull request, and now the question is, how do we test this change is doing exactly what we want, right? This is a fairly simple change, and I think if you're doing data engineering, you know that a lot of these changes and workflows are far more complex. Sometimes we're working with hundreds of lines of SQL code. A lot of business logic is encoded there. So how do we test this? How do we know that our change is doing what we want? How do we know that we're not going to break anything for other people? And one answer could be, well, we can write a unit test, right? We can say something like the bitterness units should be within a given category, but then we still can potentially not anticipate certain regressions. So what Data Diff does is whenever you make a change, it tells you exactly how a change in the source code, in this case SQL, affects the data being produced. So it tells you, for example, that number of rows in this beers table will remain the same, columns and schema will remain the same, primary keys will remain the same, but there's going to be one column which is going to be different. And overall, they're going to be 4% of values affected in a given table. And we can go and look at this diff in a greater detail. So, for example, we can look at the changes in the distributions. So here, for example, for bitterness, that was the original distribution, the pale blue, right, just 2, and now it's dark blue, 5. So you can see how this dimension distribution changed. You can also see how the values changed in this table. So it gives you an idea of, okay, now this is how my data is going to change for this particular table. Now, when it gets really interesting is that in today's data world, data pipelines don't just produce a single data set, right? We chain things into multiple tables, into multiple transformations, and then eventually we push them to BI tools, or we do something like reverse ETL, and we take this data and push it to Salesforce. And so if you're introducing any change, the chances are that you may affect something somewhere that you don't anticipate that will break. So diff also knows that there are other tables drawing data from the table we just changed. For example, apparently there is a promo deliveries table that I didn't know about, probably marketing team built it, that is going to be affected by this change. And there are other tables that are also going to be affected. What's also interesting is that we are doing analysis of the BI tool dependencies. So for example, Mode Analytics is a BI tool that we use for reporting. It looks like none of the reports are going to be affected, but high touch syncs, there are 3 that are going to be affected by this change. So one of them is actually promo deliveries. And promo deliveries in our particular case here is a so what we're doing here is basically we're taking this promo deliveries table, which if we take a look at what this table does, it segments users based on what beers they like. And then we have a high-touch integration that pushes this data to Salesforce. And then ultimately, people get promo beer samples to taste our products. So what happened here is because we made a change to the beers table, this table, promo deliveries, was affected, which I didn't initially anticipate. And because of that, our data export to Salesforce was affected, which likely means that without Data Diff, I would likely screw up some sort of marketing campaign that my marketing team would run. So what this workflow allows us to do is to be sure exactly how the data is changing when we're introducing those changes, what is going to be the impact on other data applications, BI, other tables, and then even reverse ETL, or when we leverage data in other systems like Salesforce. And all of that happens in the pull request. So when a data engineer or analytics engineer makes a change, that's right in their workflow. And it doesn't take you any effort to actually run this. So that's an example of using Data Diff to prevent preventable issues that we can introduce as data developers. Now, the interesting question is, can we also apply the same concept to the instances where it's not us breaking data, but something outside of our control breaking? One example of things breaking outside of our control is data replication. So among of you who are working in data teams, do you copy data from your transactional stores into your data warehouse? For example, Postgres or MongoDB to like a warehouse. Great. How confident are you that that pipeline never breaks? That whatever you have in a transactional store always lands in Snowflake? Like, very confident. How do you know? Okay, first year would said no, didn't test it for 2 years, assuming it's still correct. Okay. Quite. It's time skew. Right, so in general, copying data around databases is a hard problem because we're talking about hundreds of tables typically, potentially large data volumes, copying them between databases that are not necessarily conforming to the same formats. And data replication is a huge market, right? There are multiple vendors like Fivetran and Stitch, Talent. There's also multiple open source solutions. But a lot of times it's basically a time bomb until you figure out that whatever you thought is your source of truth because you exported this from production system is actually incorrect, and you've been using it for analytics for years, right? Especially if you don't have an ability to check that. So this is another example how we can use Data Diff. So it's actually an open source tool, so you can download it from GitHub. And the idea is that if we're moving data from one database to another, let's say from Postgres to Snowflake, we want to make sure that whatever leaves Postgres ends up in Snowflake. And typically, it's not just like a one-time copy. Typically, we're streaming lots of updates for many tables, so there's a lot of moving parts. And with Data Diff, you can run a simple command line, or we can also run it in Python. So here we are running Data Diff to compare Postgres to MySQL. It's just on my laptop, but I'll just demonstrate how it works. So in about 1 second, we compared about 500,000 rows across two databases, and we identified a single diverging row. So what that means in practice is that we can then take this row and request it to be resynced and fix the issue. But what is cool about this process is it runs really fast at scale. So we run some benchmarks, and you can run this on like a 25 million row data sets in less than 10 seconds, and over 1 billion row data set in about 5 minutes. So it's kind of approaching count star in terms of the speed, but it actually is able to compare huge data sets and pinpoint single values in both of them if they diverge. So pretty magical, to me at least. The way it works is through some hashing that's applied in both data sets, and then binary search that kind of finds diverging hashes. So the cool thing is it doesn't require you to actually download data in any system. So it's extremely fast and extremely scalable, very low footprint. And with that tool, you can basically guarantee that whatever data you move around databases always stays consistent. So basically, wanted to introduce you to Data Diff as a third pillar of data quality, in addition to data testing, data monitoring. And whether you are in the we break data camp or they break data camp, you can find great use to it by either or validating your own work or validating data that you're leveraging from other systems in your workflows. Thank you.
Cool. Thank you very much. So we if you will join me here, like we a little over time, so we'll do this reasonably quickly. And there were a couple of great questions during the presentation. Just one question for me. Maybe tell us a little bit about the company, when you started, how many people, whatever you can share.
Sure. So we started in 2020. We actually started working on our company the day that US went into the lockdown the first time in February 2020. So it was a really fun
Great timing.
Great time to start the company, and it forced us to actually go all remote from the very beginning. And we were in Y Combinator's summer batch in 2020, just me and Alex, my co-founder, and now Datafold is 32 people, so very exciting to see it growing.
Very cool. All right, do we have questions? In which case I will run with the microphone. So nobody wants to. Oh, all right, I will run. I promise, so I need to run.
Hi, I'm wondering, how do you track the data dependency? Like, it's basically OLTP to OLAP. There is a transformation there, and also like tables show a flow chart, right? So, in many business use cases, that can be changing really quickly, and with many dependencies adding on a daily basis. How do you track that?
So, if I understand correctly, the question is how do we track dependencies among tables and between tables and data applications? Yeah. So the answer to that is Datafold does a process which is called lineage. So data lineage is automatic identification of dependencies in the data sets. We do this both on a table level and on a columnar level. So you can track basically how data flows between columns from table to column, and then all the way to BI tools and data applications. The way we do this is by doing log analysis. So we would, let's say, if using Snowflake or Databricks, we would connect to Snowflake, we would download the logs of all the SQL statements that were executed, and then we are pretty much compiling them the way the database would, and then we combining it into a global graph of dependencies. So we know exactly how the data flows, which allows us to produce this impact analysis and show, whenever you change something, what's going to be the impact, but also maybe if you're dealing with a data quality incident, being able to backtrack that and diagnose where the issue may be coming from.
All right, one more.
Hi, you used the phrase unknown unknowns. Does that mean that in certain instances you wouldn't have to point the tool at a specific data source? So will it discover data sources as well as a discovery tool?
If I understand the question, will the tool discover data sources, or do you have to point it to a specific? Will it find unknown data sources? In this, you do have to connect it to specific data sources, like a warehouse. For example, let's say if you're using Snowflake and Databricks and Postgres, you would need to connect it just like a BI tool to all of these. But in terms of discovering, what it will automatically do is discover dependencies. So for example, you may not know where does the data come from into a given dashboard, like what is the source of data for a given dashboard. And Datafold will be able to construct this lineage to show you the picture of how all the data comes together into a given BI dashboard or application. Does that make sense?